Hello students, I'm back. This is Math 181, 4.1 related rates, and we are on problem number 4. One of the hardest things to do is to get the picture of this, and I've drawn it for you. So car A is traveling west at 50 miles per hour and car B is traveling north at 60 miles per hour. Both are headed for the intersection of the two roads. At what rate are the cars approaching each other when A is 0.3 miles and car B is 0.4 miles from the intersection? Again, you can go to Khan Academy and look up related rates, cars approaching each other, and there's a very good video of that. And he's much better at doing videos than I am, so I appreciate your patience. This is very new to me. I'm just filming this with my iPhone. So, and let's take a look. So there's the intersection, and B is going north, A is going west, and they are approaching each other at this point of the intersection of the two roads. Now, the idea that's happening is that as B approaches the intersection, A approaches the intersection, the distance between them, do you notice it changes? See, it's changing all the time as they approach each other. This is similar to the ladder problem, except for the ladder never changed. It was a constant 13, that entire problem. And let's go over here and see what we're given. We are given the rate of change of A. Car A is going 50 miles per hour. Now, this sign stuff we gotta sort out. Why negative? And it's because let's say this is distance A. It's decreasing, right? As A goes here, the distance between the intersection and where A was is decreasing, and that's why it's negative. And also dB dt, since that distance is decreasing, we say that that's negative 60 miles per hour. It was given that A is 0.3 miles, B is 0.4 miles, and dc dt is what we're looking for, right? Now, you know the relationship between A, B, and C. A squared plus B squared equals C squared. And you find the derivative, 2A dA dt, 2B dB dt, 2C dc dt. Substitute in AB. Now we don't have C, but we can find C, because at the time when B, what was B? B is 0.4, A is 0.3. We can do A squared plus B squared equals C squared, and you will get that C is 0.5. All right, I'll let you do that on your own, because I know you can do that. That's just a little Pythagorean theorem. So what I do here is I'm going to substitute in all my values. I put in 2.3, negative 50. And notice I don't solve. I just go ahead and do it with numbers in it. 2.4, negative 60. 2 times 0.5. This gives me negative 30, negative 48. This just 2 times that is 1. And I get negative 78 dc dt. So we would say the distance between the cars is decreasing by 78 miles per hour. And the last problem, go ahead and do this one. Suppose oil spills from a ruptured tanker and spreads in a circular pattern. If the radius of the oil spill increases at a constant rate of 1 meter per second, how fast is the area of the spill increasing when the radius is 30 meters? All right, here's my oil spill right here. And it has a radius, and this area is increasing as the radius increasing. And it's giving us that dr dt is 1 meter per second. We're looking for dA dt, and we want to know what's happening at the moment when the radius is 30 meters. These values that we're determining always depends on a certain point in time, and this is the time when the radius is 30. The values will change if we're talking about when the radius is 5 meters or if the radius is 100 meters. All right, so here we go. A equal pi r squared. A is changing, R is changing, so I'm going to take the derivative. dA dt, 2 pi r dr dt. Substitute in. I'm putting 2 pi. We were given that that's 30, the radius, and 1 for dr dt. Now what's the unit? I got 60 pi. So what's the unit here? Area. We are looking at meters for a radius, and so area would be square meters per second. And we have the areas increasing by 188.5 meters squared per second. Note that I will scan these and put these up on Blackboard so that you have my notes. Hopefully you took notes, and I will see you in the next section. Take care.